Greetings from Canberra, and thanks for the opportunity to bring some of the highlights of Project 2.9 Risk Assessment of Future Carbon Sources and Sinks. I am Pep Canadell, the lead investigator of the project, along with Ying Ping and a wonderful team of collaborators. Carbon fluxes, particularly biospheric, are very dynamic and sensitive to changes in land use and climate, therefore affecting the opportunities to develop and support national policies and international engagement to achieve climate mitigation targets. Neither cable nor access, which are the Australian community models, biochemical models, and climate models to assess the impact of land use change, were unable to deal with dynamic land use change. So the project was really set up to enable land use change and forest demographics, also very important, in cable for diverse applications. I'll show some of them, and its results to contribute and update the global carbon budget as part of the bigger engagement and leadership we have in the global carbon project. Now, so much of the research really went into model development, which ultimately, to enable the assessment of the potential of revegetation and conservation activities in Australia, assessment of Australia and global carbon sink dynamics, and produce national and global carbon budget data products that show how carbon dioxide and methane levels are tracking. The two major outputs of this project are truly a new cable, as I said, enabled with land use change. Here, the panel on the left, with the red box showing the new components that have gone into now model to allow the land use change and woody demography. Woody demography being really important to understand changes from land use from one estate to another, particularly if the states are moving from heavy logging, reforestation, back to some sort of a regrowth of secondary forests. Very important for the land sinks. And the other one on the right side, it's basically a land use change enabled access Earth system model. So access did not have a land use change in the past, and as part of the contribution of this project, now we do have. And actually here it shows exactly what we did, which was to take a very simple land use change which already existed in the climate model in CSR Mark L3L and couple it to access. So basically the effort has been that the actual coupling to access, which now access is able to understand the carbon consequences of changes over the last 150 years of changing tree fractions and grasses and crop fractions, as we have, changed the uses of the land, and of course, move into the future as access becomes and runs future climate models scenarios. Perhaps one of the most exciting scientific findings of applying, the full cable with all the whistles that they have gone into it for understanding the impact of land use change in the land sinks has been the fact that secondary forests are responsible for a very large fraction of the land sink, anywhere between 40 to even more than 50% of the total land sink. This is really important because it kind of takes the almost exclusive focus of conserving pristine and well-established forests into the fact that from a climate point of view, these very pristine forests and old-growth forests and well-established forests are as important as the new forests that are just beginning to regrow because the land use has changed and has enabled a woody encroachment to take over. And the focus even in avoided deforestation, again, secondary forests in many instances have been, even outside of it. And this shows that the relevance or almost equally relevance to look at this type of regrowing systems. The other thing that we did here on the right side panel is to, by being able to also have the land use change component independently from the climate component, we can now check specifically climate extreme events impacts on biochemistry and the carbon in the carbon uptake of Australian ecosystems, various ecosystems. And what I show here with the red circle is the impact of the La Nina in 2010. And I think it's really interesting what it shows, this new capability, is that the boom and bust dynamics that we usually associate with La Nina, where a lot of rain comes, everything grows, but then everything gets lost, it actually shows that there is a real positive effect in the longer term now, just a few years, of maintaining that carbon sequestration and not necessarily letting it go, as I think that usually we think on this type of dynamics. And finally, we do have actually now the capacity to take, the model and start exploring, future scenarios. Here we show a similar RCP 8.5, which is very warm scenario and very intense in land use changes, and we can actually show the effect of climate changing over 100 years. At the same time, we can separate the effect of the land use change alone. And that's what the red arrow shows between the potential and the real, showing the rest is the difference and what's due to changing climate. So we do have now a full capability that enables to do all sorts of exploration we were not before. And finally, we are, as part of our bigger collaboration and highly leveraged science we do with the Global Carbon Project, we've been able to, during the period of this project, to produce 3 annual updates of the Global Carbon Budget and 1 update on the Global Methane Budget, still not published, to be published very soon now. Now, project achievements, the Department of the Environment and Energy remains perhaps at the national level, the most important stakeholder for us. And I think that over the last 3 years, particularly over the last year and a half, I think that we have grown as more trusted advisors on any carbon cycle related matters. I personally never been so many times, in the department for all sorts of different conversations and discussions, showing that, the fact that we have actively sought, this engagement is yielding, what we were trying to do. We also began to do, I think it's a very solid relationship with the International Climate Change and Energy Innovation Division of the department. And I believe that if we continue and we grow it, as we move into the next project, I think that it can yield something even more useful that perhaps we've been able to achieve. Significantly, we have contributed, of course, to a lot to national and international research, which is enable land use change in access, increase understanding of the role of secondary forests, support submission to CMIP 6 of our Earth System model. And I think there's a much higher awareness of global emission dynamics due to almost real-time provision of data that we do with the Global Carbon Project, as we put these products that help us to track changes of emissions, methane, and CO2, which are really, used and looked after from, many and sought after many governments around the world. In terms of project impact, I think that the Global Carbon Budget, everything that gets released, now it has become the authority of really putting the pieces together every single year. The top left panel really shows, standard media analysis, showing 86 countries with almost over 3,000 stories, bringing the new carbon budget to bear into this broader community. We regularly have mentions, and we ask, both at the Conference of the Party and SAPSTA meetings to provide data. And in this particular case, bottom left, the UN Secretary himself, highlights the work of the Global Carbon Project as he speaks to 116 nations at the COP23 in 2017. We're also very delighted that WMO, the World Meteorological Organization, for the last 2 years have invited us to develop a whole page for the Global Carbon Budget into the WMO statement the state of the climate. And we're really proud of it because these are statements that have been exclusive of climate and nothing else. And the fact that now they embrace the work of Carbon Budget is an incredible sign of the value of what we do. And finally, I think we're also proud of being engaged on the broader discussion of both in Australia and overseas, through blogs and articles, reaching, a broad audience of the public sector. And I think that, the conversation has been a wonderful conduit for us to do partially this job. And finally, next steps. I think that so much of the next steps are really driven by what we hear from particularly the department that they have most interest for us to pursue. One is to continue exploring implications of land use change and looking at some of the multiple data sets that exist both nationally and globally, explore carbon and water, because cable also does water, consequences of climate scenarios, particularly the new set of scenarios coming out, respond also to stakeholder interests, on blue carbon. And we'll not do this thing ourselves. We don't have the capacity, but we do have the capacity to engage with partners, mostly at the university doing this work, and the department itself. Focus more on more than carbon, more methane and N2O as kind of non-CO2, really important gases, particularly for countries like Australia, where non-CO2 are so important. Provide and package information relevant to the Paris Agreement for global stock take. The department has specifically asked us to think about how we can contribute to these components. And finally, just to say that the continue and enhance close engagement with DOE, it really remains perhaps, no doubt about it, the most important national stakeholder for this project. And I think that as we move to the next project, starting the next financial year, I think that we will be able to bring quite a few of these components into one of the products we have basically promised to deliver as part of the new project, which will be a whole new greenhouse budget for Australia, with a lot of not just national data sets, but a lot of the global data sets that are looking at specifically Australian to see how much we can extract. With this, look, thank you so much for your attention. This has been a little bit kind of quick overview. I'll be, of course, delighted to answer any questions